Hey folks, in this video I'll introduce the idea of the scheduling problem. So what is the scheduling problem? Well, even before I go to my slide, maybe I can back up a second and give you guys a real example. So consider your courses that you need to take, right? You need to take, for example, SER222, okay? I drew 226, I don't know how that happened, I really don't. So I do have 222. And you have this course because you have things that come after it, right? You have things that come after it, things that come before it. And actually, we're going to add one of the things that comes before it is, for example, 205 CSE, right, or discrete math, 243. So notice I'm drawing a directed graph out. And 222 is a prerequisite for other stuff. So I'm just going to assume it's a prerequisite, not a co-requisite. Stuff that may go after 222 is, for example, 334 or 216. 216, there you go. This is a graph of our dependencies, right? So basically showing what depends on something else, right? In order to do 222, you have to have 205 and 243. In order to do 334, you have to have 222. Okay, so this is fine. And if you look on my ASU or you look on the ASU website, you'll find pictures like this for all the different majors that basically show how are all the classes related to one another. Why do we need to know this? We need to know this so that we can know what order to take them in, right? So you can't take 334 and then a year later take 205. That doesn't make any sense. The order is the opposite way, right? So these are our dependencies here, right? And from our dependencies, we have to create this kind of dependency order of, oh, hey, I'm going to take 205 in this session, then I'm going to take 243 in the next session, then I'm going to take 222, and then I'm going to take 216, and then I'm going to take 334. Right, and this is, these are different years, right? So this is 2018, this is 2019, right? And this is your actual semester, no, this is 2020. We have kind of these overall rules for how the course should be taken, and we need to figure out, right, based on those rules, what order to take them in, right? And I do have some flexibility here, right? You can look at my picture and you can say, oh, hey, that's non-unique, right? I mean, I could take, I could swap these, right? These can be in either order based on my picture here, right? There's no interdependence there, so I don't need to worry about that. I could also swap these over here, right? Those would also be fair game for me to exchange. Again, right, there's no dependency here, so it's fine. But I do need to make sure, right, that before 202 occurs in this list up here, right, that I've done 205 and 243, right? So I have some sort of order there. And so, yeah, that's how the world looks, and this is a variant of the scheduling problem. So the scheduling problem is basically saying that we have a dependency graph, right, where one thing requires another thing, and we want to know how it is that we can maybe traverse this graph in an order that we obey those dependencies. Okay, so this, right, you can take to be a real old example, right? This is something you have to deal with every single semester, trying to figure out what classes to take, right? And there has to be, right, some way basically that for all the requirements for your classes, that after the 4 years of your program, right, you are able to take all the classes, right, in the right order, you have all the prerequisites lined up, right? You don't get stuck in a situation where it's like, oh, I can't take 334 because I don't have 222, right? You don't want to get stuck like that. So this is a problem, right? You have to kind of worry about. This is basically your advisor's life, right? Your advisor's life is figuring out the top from the bottom, right? All right. So more formally, right, this is what we call a scheduling problem. A scheduling problem basically is expressed on a dependency graph, right, where I have, A arrow B, which implies A must happen before B, right? So I must take 205 before I take 222, right? That's a hard prerequisite. I can't do that one before the other one. Or, right, if I have, so A must happen before B, right? Or A is a dependency of B, right? So the arrow says go from here to there, okay? So A and B could be tasks, right? They could be classes, right? So we use the example of classes. They could also be other things, right? So maybe A is get out of bed, right? Of bed, versus B is eat breakfast. And probably you're going to do those, get out of bed first and then eat breakfast. Although I suppose one could do them at the same time. But yeah, you have basically two things, right, that are tasks, or here, right, courses in our example, and they need to happen in a certain order for it to be valid, right? It doesn't make any sense for me to take 222 and then 205, right? It doesn't make any sense for me to eat breakfast and then get out of bed, right? So yeah. And our overall problem here that we want to solve is to produce an order of what vertices, right, meaning what task or what class I should visit, and in what order should I visit them, such that I meet all of the dependencies, right? So I've handled A before I get to B, right? I want to handle all the dependencies before I get to the dependent. Okay, and that's my problem. I want to figure that out. So that's our scheduling problem, and that's going to be basically the main topic for the rest of the videos in this module, because we're going to go into this into depth, right? We're going to try to figure out, how to produce that order. That order is going to be something we end up calling a topological sort, which is what we'll be introducing in the next video.